Hello, I'm Chuck West. Welcome to another edition of the Craps Strategy Project. In this video, we're going to do something a little different. We're going to look at dice statistics and collection strategies. You may be a newcomer to dice statistics, or maybe you've heard that the average roll length is 8.52 throws long. But what does that really mean, and how can you use that information to manage your bets and your expectations? And what about collection strategies? A lot of craps strategies are designed to get your bets paid for, so you're playing with casino money. But what do you do then? Do you just collect, or press and collect, or what? We're going to take a look at some options and test them with simulations of 2.5 million shooters. The results might surprise you. Stay tuned. Let's start by talking about dice statistics. It seems like a simple topic. You roll the dice, count up the pips, and that's the number you threw. But in craps, everything depends on the distribution of numbers that can be thrown. The casino assumes that throws will be random, and the payouts on all of the bets are based on the frequency of each result over a large number of dice tosses. So how can you use dice statistics to your advantage? That requires a little background. Most people know the basic, but there's a lot of misunderstandings of dice statistics and what to expect from each roll. The first thing to understand is that even if a number is considered random, it can still obey a distribution. Dice throws are considered random, but you can only throw certain numbers, and some of those numbers appear more frequently than others. A pair of dice can produce the numbers 2 through 12. There is only one way to make each of the 2 and 12. There are 2 ways to make each of the 3 and 11. There are 3 ways to make each of the 4 and 10. There are 4 ways to make each of the 5 and 9. There are 5 ways to make each of the 6 and 8. And there are a total of 6 ways to make a 7. All told, there are 36 dice combinations. Now, if we consider the ways to make a 7, that's 6 of the 36 combinations, or 1/6, which means on average, 16 2/3% of rolls will be 7s. So if 1 out of every 6 rolls is a 7, why isn't the average roll length 6? The answer is because of come-out rolls. Remember that the shortest roll you'll ever get at a craps table, assuming you don't run out of money, is 2 throws long. That's because if your first throw is a 7, it's considered a winner and you automatically get another throw. Any other numbers also allow another throw. So with 2 guaranteed throws, the average roll is already up to over 7. And that doesn't count any come-out 2s, 3s, 11s, or 12s that you throw. You can also hit your point and have more than one come-out roll. So if we take all this into account and do the math, we find that the average roll length is about 8.5 before you 7 out. But what does that tell you, and how useful is that number? Does it mean, for instance, that half your rolls will be that long? Or that you have on average 8.5 rolls to make your money back? The short answer is no, and we're going to look at why that is. The first thing to consider is the median roll length as opposed to the average. The median of a distribution of numbers is the value that half the numbers are less than or equal to and half the numbers are greater than. The median roll length is the length that half the rolls are longer and half the rolls are shorter than or equal to. In this case, that number is 6. Consider, for instance, this series of rolls. 9 shooters rolled the dice. The first shooter had only 2 throws, a 0.7 out. The second shooter did only a little better and got in 3 throws. And so on until the 9th shooter, who had a very nice hand with 33 throws of the dice. Now, if we add all those numbers up and divide by 9, we get an average throw length of 8.55. But you can see that's really skewed. Most of the rolls were shorter than that. So if we look at the median value, the value in the middle, which is 6, we see that half the rolls are longer and half the rolls are shorter. The point here is that the average can be skewed upward by 1 or more very large numbers. The 33 could, for instance, be a 165, and the average would go way up, but the median would stay the same. The reason for the skew is that even though occasional rolls can be very long, the shortest roll can never be shorter than 2. But there is another issue to consider when considering roll length as a statistic. Consider this somewhat unlikely roll. As you can see, not a lot happens for a while. It's just a long come-out roll. Even the pass line bettor only breaks even during the come-out throws. The roll is 12 throws long, but that's not very informative. Nothing really happens until the 11th throw, when the point is set to 8 and the puck is turned on. It is then followed immediately by a 7, and the roll is over. If you heard that a roll was 12 throws long, you might think it was a decent roll. But here, it was terrible for the place bettor. So I defined a statistic that I call at-risk rolls. These are rolls where your bets are at risk, and conversely, you can make money on place bets. In this case, the at-risk roll length is 1. That's because the only time you could lose your bets was after the point was set, and the next throw, the first at-risk throw, was a 7. Now, we are talking about place bets and the like here, and following the puck. If you are making come bets or lay bets or any other bets that don't follow the puck, the situation becomes a little more complicated. But for most of the strategies that we consider here at the Craps Strategy Project, the bets tend to follow the puck. For the ones that don't, I make a note of it and adjust the statistics accordingly. But for this video, the at-risk roll length is important to consider. So we've seen that the average roll length is about 8.5, and the median is about 6. But the average at-risk roll length is exactly 6. It's just a coincidence that this is the same length as the median roll length when counting all rolls. But the median at-risk roll length is only 4. Remember, the median is the number where half your rolls are longer and half your rolls are shorter. That means that half of the time, you have 4 or fewer throws to execute your strategy before a 7 shows up. But it also means that half your rolls are longer than 4 throws. So how much longer? And how are the throws distributed overall? This plot shows the length of a roll versus the cumulative percentage of rolls of that length or shorter. On the horizontal axis here, we have the length of rolls. On the vertical axis, we have the cumulative percentage of total rolls. The cyan line is for all rolls, and the red line is for at-risk rolls. The way you would read this graph is, for instance, to consider a point here. It represents a roll length of 2, which happens about 11 or 12% of the time. Compare that to this point, which represents rolls of length 3 or shorter, meaning rolls of length 2 or 3. And they make up about 22% of rolls. That includes the 12% of rolls that were length 2. As you can see, most rolls are under length 20, more than 90%. In fact, if we zoom in on just the topmost part of the plot, we can see more detail. Now we've zoomed in on just the very top of the plot. I've started the plot where both the all rolls and the at-risk rolls start at 17 throws. You can see that for all rolls, more than 90% of rolls are 17 throws or shorter. And for at-risk rolls, more than 95% are 17 throws or shorter. If we go out to 40 rolls, we can see that both types of roll are well above 99%. That is, more than 99% of rolls are shorter than 40 throws. So we know that very short rolls make up half of our rolls, but now we also know that longer rolls are quite uncommon. Rolls of 17 throws or less make up more than 90% of all throws, and rolls between 17 and 40 rolls make up another 9%. That leaves only 0.3% of rolls that go more than 40 throws. That's 3 in 1,000 rolls. So what does that mean for us as players? That's going to depend on how we play. So that's what we'll look at next. We're going to switch gears a little bit now and talk about collection strategies. What do I mean when I say collection strategies? Basically, I'm assuming that you've played some other strategy, maybe even one of the ones that we looked at here on the Craps Strategy Project, like Split the Sisters or Squeeze Play. And you've gotten to the point where you have $64 across, or some multiple of it. And now you need to know what to do. What's the best way to proceed? We're going to look at a few alternatives, but first let's talk about methodology. As a brief recap of my methodology, we're going to be using place bets only, no prop bets, no carnival bets, and we're going to start with a simple 64 across. We'll look at 5 different strategies. There are more possibilities, but these cover a pretty good range. Let me know in the comments if you want to see something else, and if I get a few, I'll do another video. I use custom computer programs that implement the strategies. Shooters are simulated in groups of 25 because that seems like a reasonable session at the craps table. I then run 100,000 realizations of the groups of 25 shooters. 100,000 times 25 equals 2.5 million total shooters for each strategy. All strategies get exactly the same set of dice rolls, so there is no difference among the strategies attributable to dice variance. I assume a table limit of $500 on place bets. That means $600 on the 6 and 8 and $500 on the other numbers. This is a common limit at $10 tables, but it only affects a few rolls here. And finally, bets on the 4 and 10 become buy bets when they reach $20. The VIG is taken when the bet pays out. In this video, we'll be looking at 5 different collection strategies and seeing what kind of results they produce. The first strategy is simply collecting. Here we'll collect the full winnings on every hit and never press any of the bets. This isn't necessarily a strategy that anyone would play, but it provides a baseline against which we can compare the other strategies. The second strategy is press and collect. This is a commonly used strategy where the bets are pressed the full amount of winnings every other hit, and the winnings are collected on the hits in between. The amount of the press is rounded down to the nearest increment of $5 or $6, depending on the number. The third strategy is based on Casino Quest's triple luck strategy. The bets are power pressed twice before collection, and then the process repeats. The bets are increased by as much as $4 if that makes them round to even $5 or $6 increments, depending on the number. And that's why we call it a power pressing strategy. The fourth strategy is press 1 unit. It's also commonly used. Here the bets are always pressed by either $5 or $6 depending on the number, and the remainder is collected. Finally, the fifth strategy is press inside. In this case, hits on the outside, the 4, 5, 9, and 10, are used to press the 6 and the 8, and hits on the 6 and 8 are collected. It's a bit like a tower strategy, but the tower numbers, the 6 and 8, are not regressed when they hit. We ran all of these strategies through the programs and collected the statistics. The comparison looks something like this. Here are the results presented as the number of bets won versus the length of the roll. On the horizontal axis is the length of the roll. On the vertical axis is the number of bets won. Here a bet is $10, so just multiply bets times $10 to get winnings. Each of the strategies is represented by a colored line. Triple Lux is blue, Press and Collect is red, Press Inside is green, Press 1 Unit is magenta, and Simple Collect is cyan. All of the strategies start at the same point, the first roll length, which, as we found earlier, is 2. That's a 0.7 out. At that length, you lose 6.4 bets, or $64. That's your full 64 across. Now, that's kind of an arbitrary starting point. I could have assumed that your initial bets were paid for by your starting strategy, but there's another implicit strategy here, which is just to pick up your $64 and refuse to play. That's not very fun, but it is a viable option if your starting strategy has left you with a profit. And it's the strategy that I'll measure all the others against. So 0 is our baseline, and minus 64 is our starting point. We'll look at all of that more closely in a minute. There are 2 ways to read this plot. The first is to consider some roll length and see how much each strategy earns. For instance, at 30 rolls, you can see that Simple Collect earns about 20 bets, or $200 on average. Well, Press and Collect earns more than 30, say 35 bets. And Triple Lux earns more than 50 bets on average. The second way to think about this plot is to consider an amount of money you want to earn, and then see how many rolls each strategy will take to get you there. For instance, let's say you want to win 20 bets, or $200. You go across from the 20 and see that Triple Lux takes about 22 or 23 rolls to get there, while Press 1 Unit takes 25 rolls, and Simple Collect takes 30 rolls. For now, you can see that for long rolls, the Triple Lux strategy is far and away the best. It starts out slowly, but after 22 or 23 rolls, it really takes off. The next best for long rolls is the straight Press and Collect. Its start isn't as slow as Triple Lux, but it also doesn't have quite the dramatic increase. The other strategies are a little worse for longer rolls, up to Simple Collect, which just stays linear forever. But let's take a closer look down in this region, where we know that more than 90% of rolls happen. Here we zoomed in and are looking at just the first 21 rolls. It's a very different picture now. Simple Collect gets to the break even fastest, at roll 9 on average, and outpaces all of the other strategies all the way up past roll 16. Remember that 90% of your rolls are 17 tosses or less. Triple Lux, on the other hand, actually loses extra money for several rolls. That's because we're power pressing the bets while not collecting anything. And it doesn't break even until after roll 14. It doesn't catch up to Simple Collect until the 19th roll, and doesn't overtake the other pressing strategies until roll 21. That's a huge disadvantage to overcome. If we look back at our cumulative roll frequency graph, we'll see that a roll of length 21 or less accounts for almost 95% of all rolls. That means that only 1 in 20 rolls will go longer than 21 throws. I'm telling you this just to make clear some of the statistics that are coming up later. Why, for instance, even though triple Lux is wildly profitable at longer roll lengths, it isn't necessarily the best strategy. Now we can look at a breakdown of the individual strategies. If you've seen any of my other videos, you're familiar with these plots, but I'll briefly explain in case you're not. This is an example of the plot for the press 1 unit strategy. I've created 100,000 random realizations of crap sessions. Each session had 25 shooters with random dice rolls. Some of those sessions won money, and they were plotted to the right of the zero. Some lost money, and they were plotted to the left of the zero. Each time a session won an amount that fell in a certain range, a bin, the count for that bin was incremented by 1. Thus, on the vertical axis, we have count, or how many times a certain outcome happened. Each of the little blue rectangles represents a particular bin, an amount won or lost. Its position on the horizontal axis tells you what that amount was, and its height tells you how many times it happened in the 100,000 sessions. Here, for instance, is an outcome that happened almost 1,000 times. It represents sessions that won somewhere between 0 and 200 bets. It looks like less than 100, so let's just call it 70. So in the 100,000 sessions of 25 shooters, about 1,000, or 1%, won about 70 bets, or $700. Or consider this outcome. It happened more often than any other outcome in the 100,000 simulations. It's what statisticians call the mode of a distribution. It happened more than 4,500 times. Notice how it is to the left of the zero line, which means it lost money, maybe about 35 bets, or $350. Again, that's for a group of 25 shooters. So ultimately, if you were to add up the height of all the little blue rectangles, you'd get 100,000. If instead you multiplied the height of each rectangle by its winnings or losses and then added them all together, you get the total net winnings or losses for the strategy for the 100,000 shooters. If you divide that by 100,000, you get the mean or average result you can expect from a group of 25 random shooters. The mean is showed by the red line. The mean value for this strategy is about minus 12.2 bets, or minus $122. That's not too bad. Remember, you're putting $64 at risk 25 times, so a loss of 122 is manageable. Keep in mind that craps is a negative expectation game, so any strategy is going to lose money over the long run, unless you can control the dice, but that's the subject of another video. Maybe we'll do that next. The last thing we'll look at before moving on is the median outcome. As we discussed earlier, the median outcome is the middlemost outcome. Unlike the mean, it isn't weighted by the amount that's won or lost. Here, the median is shown by the cyan line. The median in this case is minus 18.3 bets, or $183. So half the time you'll do better than that, and half the time you'll do worse. Now let's look at our first strategy, Simple Collect, and we'll see what its plot tells us. Here we see the distribution of 100,000 realizations of 25 shooters for Simple Collect. The mean of the results is about minus 10 bets. That's a pretty good result. It's not 3-point Molly good, but it's good for a strategy that doesn't do anything. The median is about minus 12 bets. That's really good too, and it's close to the mean because the distribution is so symmetrical. Another statistic we can look at is the standard deviation. It's a measure of the central tendency of a distribution, that is, how compressed or spread out it is. Here the standard deviation is about 33.5. What that tells us is that if you take the mean and add the standard deviation, and take the mean minus the standard deviation, you get a range of plus or minus 1 standard deviation. And statistics tell us that about 68% of the outcomes will fall in that range. The magenta dashed line shows this range. Here, it goes from about minus 43 bets to plus 23 bets. Now, if you consider the mean plus or minus 2 standard deviations, you get a range that encompasses 95% of the outcomes. Here, that's from about minus 77 bets to positive 57 bets. Playing this strategy 95% of the time, you can expect to lose no more than $770 and win no more than $570. So this is a very conservative way to play. No big surprises. You won't lose a lot, but you won't win a lot either. Next, we have the most basic pressing strategy. Each time a number hits, you press it 1 unit. 1 unit on a $10 table is either $5 or $6. $6 for the 6 or 8, and $5 for the other numbers. As you can see, the mean at minus 12 is a little worse than for simple collect, meaning that over a large number of sessions, it will lose a little more, but just a couple of bets. The standard deviation is also larger, meaning that you would experience more variance playing this strategy. And for the first time, we're starting to see a little bit of skew. Skew is a measure of how asymmetrical a distribution is. If the skew is positive, that means the distribution has a heavier tail in the positive direction than in the negative. That's the result of starting to have a few large wins due to the pressing. We'll see more skew with other distributions. Overall, again, this is a fairly safe, conservative strategy. Here we have the distribution for the press inside strategy. The idea here is to press the most likely numbers to hit and collect them when they do hit. The results here are not much different from the press 1 unit strategy, with a mean of 12 and a somewhat higher standard deviation. The skew is also about the same, so this strategy doesn't have a lot to distinguish it. That makes sense. Even though you are pressing the likely numbers, those numbers pay less, so the strategy is mathematically very similar to press 1 unit. Here's the plot for the press and collect strategy. As you can see, things have changed a lot. Each of the bins, the blue rectangles, has become much wider. That's because I keep the number of bins the same for each strategy, but now we have a much wider range of outcomes. You can't really see them, but there are bins in the 400 to 800 range, as well as off the plot to the right. These are very low-frequency outcomes, but they do happen. These large outcomes give the distribution a much larger skew. It's now up to 12, where for the previous 2 strategies, it was about 1. Despite these large results, the mean, at about minus 13, is still just a little bit worse than the previous strategies, though the median and the standard deviation have both gone up quite a bit, meaning that you can expect a lot more variance with this strategy. Although this strategy allows for some very large wins, exceeding 1,000 bets or $10,000, the first 5 bins account for 99% of all the outcomes. That means for about 1 in 100 sessions at the table, you can expect a win of greater than 200 bets, or $2,000. Which brings us to our last strategy. Here's the plot for triple lux. Like press and collect, we have wider bins because more outcomes extend to the right of the plot. In this case, however, the frequency of outcomes with wins over 200 bets is up to about 5%. That means you can expect to win $2,000 or more in about 1 in 20 sessions. Those improved odds are offset, however, by a much higher frequency of large losses. The standard deviation has also increased dramatically to 208, meaning you can expect a lot of variance among your sessions. Overall, this is a good strategy for a high-risk player who can tolerate significant losses, but loves the thrill of winning big. Now let's take a look at how the strategies we've discussed compare to one another. Here, our 5 collection strategies have been added to the table of strategies that we've looked at in earlier videos. They're highlighted at the bottom of the table. If we compare the means and medians of our new strategies, it's clear that simple collect is the lowest risk. But also, it never wins a lot and is fairly boring to play. Press 1 unit and press inside are statistically very similar to each other, and there isn't much reason to prefer one over the other. But neither has much to offer in the way of large payouts. Press 1 unit, in particular, is easy to play, and the dealers will pick up on it very quickly. It's not until you get to press and collect and triple lux that you get the large skew that indicates big payouts are common. But the triple lux, as we said, is a high-risk strategy. Its mean is substantially more negative than press and collect, and its standard deviation is huge. Press and collect seems like a happy medium. Its mean is only somewhat worse than simple collect, but it has a huge skew thanks to its ability to take advantage of longer rolls. It's not quite as lucrative as triple lux on very long rolls, but for most rolls it's considerably better. One idea would be to use a strategy like squeeze play to establish your 64 across mostly paid for, and then use press and collect or triple lux if the roll continues. Another idea would be to play simple collect, but combine it with some hard way or other prop bets to make it more exciting and give yourself a chance for a bigger payout. There are a lot of options, but ultimately this is just information on how things behave statistically. You'll have to pick your own way to play based on your risk tolerance and what makes the game fun for you. Here we have the zoomed-in roll length versus winnings plot again. When looking at this plot, one might be tempted to wonder why not stay on simple collect track, and then when the other strategies cross over it, like here or here, jump to one of them. The answer is, of course, that doesn't work because simple collect bets are still at their starting point, but the other strategies have all been pressing their bets up. So the starting point is much different. You'd effectively have to reinvest all of the winnings you'd collected and press up your bets, which would be like starting over with higher bet amounts. So the slope of the simple collect line would be steeper, but you'd have no winnings, and you'd be 16 throws into the roll. So that's the story for dice statistics and collection strategies. Keep in mind that all of this was based on random rolls of the dice. If you have shooters that can influence the dice to get fewer 7s, then you'll do significantly better. But that takes a whole group of shooters who are consistent. Otherwise, you'll want to vary your betting style to suit the shooter. As always, I'm happy to take suggestions. Let me know what your favorite strategy is, and I'll try to get to it. Until next time, thanks for watching, and may the dice roll in your favor.